You're going to Florida, Shania. That sounds wonderful. Where are you going in Florida? Anybody going anywhere for spring break? I'm not going anywhere for spring break. I'm going to be holding my baby. Oh, stop it, Disney World. We love Disney. We actually went during the pandemic, like days after it first opened, and there was like no one there. It was the coolest thing. I like didn't realize how long the lines were for things, but you could just like walk right on and they would be like, "Oh, do you want to go again?" It was so fun. Anybody else traveling for spring break? Any travelers? Oh, that will be so fun, Shania. Florida is beautiful. It's my favorite place to visit. We try to vacation every year, and I just can't go anywhere other than Florida because it's just so beautiful. JB will be here eating mac. Xavier used to live in Florida. Where at in Florida? I know. I because my husband and I work from home, I feel like we've prioritized vacation just because I feel like when we're home, we just act like kind of default to work mode. An hour north of Lynn. Okay, yeah. Cool. It's beautiful down there. That's a pretty central area too to be able to get to both coasts. So fun. Well, feel free to, if anyone else is traveling, has even plans, doesn't have to be traveling for spring break, feel free to Caden's dogs playing games, staying at home and playing games. That's fun. Caden always has his dogs out there. Huh. They're part of our class. All right, so today we are going to take a little bit of a deeper look into what we were talking about yesterday. So yesterday we talked about renewable and non-renewable resources and then some of the problems they pose on our environment. One second. All right. So we are going to look today at some effects of that pollution. All right. But before we do that, I want to show you something that I created for us. I'm going to stick it in the classroom and then we'll come back and read the goals. I created for you. Wait a minute. Where'd it go? Come back. Okay, hold on one second. Let's pull this up. I'm going to share my screen with you. It must have logged me out. That's not cool. I created a really fun Nearpod. It's not anything. Oh, I'm sorry, Chandler. That's not cool. I'm going to share with you something that you guys can go explore here after class. It'll be in the classroom. All right. But I put together a little Nearpod for you. Here. Let's do live, I guess, for right now. But you can kind of check out all of the devices that are non-renewable and renewable resources have. Anybody know what this is? What is this? Anybody recognize this puppy? So when you go in and mess with this, yeah, it's a solar panel. So when I'm going to put the Nearpod code and everything in the classroom, you'll be able to use your mouse to move it around and check out all of these different devices that are energy providers. All right, this is what happens when you tap for oil. This is how you tap for oil. It's the device you use to tap for oil. You can do the explore. Ah! My computer is kind of slow today. I'm not gonna lie. Let's come back. A nuclear power plant. All right. Check out that. Back here was a hydro, a dam, a water dam, what that might look like. How we funnel energy or funnel water to a place where it can be utilized for that. There's nuclear. I think there's one or two more. Two more. All right. And you guys are going to be able to come and check these out, explore them, move them around all on your own. Okay. So you'll be able to explore those forms of energy. That again will be in the classroom after class today so that you can check that out. Oh, yes, your cat too. Awesome. Does anybody want to read our goals today? What are we going to do? Again, you're going to see that most of them are going to be down here in the knowledge section. So we're really going to just get some basic information about these today. Who's going to read for me?
Define the greenhouse effect. What is the Kyoto Protocol? And define pollution.
Thanks, Kaden. I appreciate that. So let's look at this right here. If I put nothing else on the board, this is what I really like to do, guys. I want you to take this strategy from me because it's just good, okay? I only teach you good things. I want you to pretend, that there's nothing else on this slide, but you came to a diagram on your test. And it's a question, it has a lot of words, and it has a graph. I want you to get really good at just pulling out important things. All right, so what does this graph show us? What does this graph show us? First of all, what does the line do? We don't need to get super analytical. Does the line go up or does the line go down? Everybody type in chat. Up or down? What happens to the line? All right, I really want you to take these strategies because honestly, this is the most important thing. You might not know anything about what the question is asking as far as content, okay? But if you guys can use these things to simplify questions and decode questions on your test, you guys are going to ace it, okay? So look, the very first thing we saw, we look at a graph, there's a line. We're like, okay, that line is going up. All right, let's look at the bottom because the bottom tells us that it's going up by what? Up over what? Down here, it's showing us the year. And a year is a measure of what? Good, time. So it's showing us that something is going up over time. Up over time. Now let's look over here on the left-hand side. What are they measuring over here? Parts per million. How many of you use parts per million on a regular basis? And are like just super familiar with ppm? Be honest. Not not most of you, right? You don't measure a whole lot by ppm. Parts per million. What do you know about the numeric value of a million? Is it big or little? Good, you know what it means. Good. Yeah, people are like, is it air pressure? Yes. So we're looking at a part of a million, okay? So we're looking at something pretty vast. We're looking at something pretty big that over time is going up. All right. If we look up here at the title, it'll tell us what we're like. We don't need to even read the whole title. What are we talking about? What is going up? We don't even need the whole title. What does it look like? Good. CO2. So just by like looking at this graph and making some really quick assumptions, we can say, one, this line is going up. It's going up over time. It's something really big. The ppm we could almost completely disregard. And then looking at the title for what is it that's going up. So if you were asked a question on the end of course exam, you could go already to, without even reading everything that I just blacked out, you could go straight to the answer choices and know that you're looking for something that's talking about carbon dioxide going up over time. Give me in poll how many of you, like, if these kind of questions when you see them on the test stress you out. I'm raising my hand because when I see questions like this on tests, or I just see them in general, even on a slide in class, it like somewhat induces stress to me because it's just a lot of information. It's a lot of reading. And then I know I'm going to be expected to analyze something. And sometimes that like just triggers stress, even if it is something that I can pretty easily figure out. So what I've done over time is we just did is learned almost coping methods of decoding these questions and making it a little bit easier. So I really want to start practicing this over the next couple weeks because I really think it's important for your success as we get ready for this biology and of course exam that you're going to have in the next month. Okay. So let's go ahead and get rid of these. All right. And all this is explaining is the exact same thing, that we're going to look at how global temperatures are increasing over time. All right. This is right here a volcano in Hawaii. All right. And believe it or not, just like we talked about, just like our emissions put out carbon dioxide that are harmful to our environment, so do volcanoes. Okay? So do volcanoes. Has anyone ever been to Hawaii? Anyone ever been to Hawaii? Yes, the AOCs are in April. I've only been to Hawaii because my dad took me when I was in college. It was his dream to take all of his kids, well, his three girls, to Hawaii before we got married and moved away. But you can actually go visit volcanoes. I know, isn't that sweet? It was amazing. And it's a trip that I don't know that I'll ever be able to make on my own. So I'm super thankful that he saved for that and made that commitment to take us. But we actually went to the top of a volcano in Hawaii. All right. And they did. It was really cool. Up here at the top of the volcano, it looked like the moon, just like completely ashen. And then what you did is we actually took a bike tour all the way down the volcano. It was really cool. All right. So what we're going to be looking at today is how carbon dioxide outputs really can affect what we call our ozone layer. All right. We have a layer called the ozone layer, and we have what we call the greenhouse effect. What does a greenhouse do? What does a greenhouse do? Not our world like a typical greenhouse. They're growing spaces, right? What does a greenhouse do for plants? Like you can visit greenhouses in your area. It helps them grow, right? What's important for plants to grow? A lot of the time they're in glass buildings, right? So they can get the sunlight in. Good. What happens if they have a lot of sunlight, but they don't have a like, why do they try to control the temperature? What can happen if there's too much heat? It can evaporate the water from the plants, right? And dehydrate them or kill them. So a greenhouse is it's a really safe place for plants. Okay? It keeps it warm, it keeps it moist, right? It keeps it a lot of times very humid in there, like it is in the summer, where the water in the air is dense. And so that's kind of what happens. That glass dome and that humidity in a greenhouse, I want you to think about those glass roofs on a greenhouse. Okay? Because they let the sunlight in, but they keep the water like moisture, the humidity from exiting out of the greenhouse. Does that make sense? It lets the sun in, but keeps things from leaving the environment that it doesn't want to leave the greenhouse. And that's kind of how our ozone layer works, and that's why we call it the greenhouse effect. Okay? So the natural greenhouse effect, it's going to let the sun in, right? So we've got our atmosphere right here in this ribbon, and then we have what we call our greenhouse gases, which are, look at those, it's CO2, CH. What are those what's in both of those molecules? They're so important for life. Yeah, remember we learned about carbon literally in unit 2. And we are in like unit 5 of semester 2. And we're still talking about carbon. So now we're seeing why that is so important, right? So what happens is the sunlight, it comes in, and then things from our earth come back out, like they're going to bounce back out to space. But what this greenhouse gas does is it allows things to reheat and go back into the earth. Okay? The heat is absorbed out, but it allows things to go back in. All right, so look, sun radiation comes in, radiated heat. Some of that is sent out into space, and some of that comes back to the earth. Over here, it's different because the sun brings in our heat. And look over here, less heat escapes into space. All right? So what we're doing is by thickening this layer, we're actually not allowing things to cool or the heat to escape into space before returning back to our atmosphere. All right? Which is probably what you're most familiar with as far as the term as, have you ever heard of the term global warming? Global warming. Anybody heard of it? Yes, no? Yes. Awesome. When they're talking about global warming, they're talking about this situation right here, where that ozone, that greenhouse layer gets thicker, does not allow things in our atmosphere to cool, therefore making our overall earthly environment more warm. Okay. So this Kyoto Protocol that Caden read about, I want you to just associate it with this. It is a commitment. All right. This is like just kind of a commitment is what? What is a commitment, guys? If I make a commitment, what does that mean? No one? A commitment is a promise. Okay. A commitment is a promise to reduce carbon emissions. So this is when scientists got together in the United Nations in 1997, and this protocol was just like, hey guys, our environment is getting so warm because we're putting out so much carbon dioxide. Let's work together as the United Nations to put off less carbon dioxide, okay? Yeah, no, I understand that, Chandler. Ooh, Kate and I like that. A vow. Yes. Good. So let's take a minute. I want to watch a portion of this video. It's so good. It explains climate change a little bit better than I can. Now, know this too. Climate change can be a political topic, and that basically is outweighing risk and reward. All right. There are risks and rewards to everything in life. Everything in life there are risks and rewards too. Some people don't like tapping into our coal and oil and our non-renewable sources because of the emissions and because of global warming. However, when we don't do those kind of things, it does make us more reliant on other nations for things like we're talking about electric cars, okay, batteries for all of these things that also make us reliant on other nations. So where there are less emissions, we become reliant on other nations for resources. So there are just give and takes to everything. And the cool thing about you guys right now in your life is you get to be like little information collectors. Or you can choose to have the same political beliefs and understandings as your parents do, or you can take this opportunity to absorb all the information for yourself and make those decisions on your own. A lot of the times, they are heavily influenced by our parents. I know mine are. All right. I still, even after collecting all the information about things myself, I have come to some of the similar conclusions, but I do also have small disagreements with things. So it's not all just about like policy and politics and believing exactly what you are taught to believe, but really being just information collectors and deciding these things for yourself. All right, we're going to watch not this whole video. It's 6 minutes, but there are some really good components that I want you to hear. We also may fast forward them a little bit. All right, I'm going to move it forward because that I don't think is as important, right? And again, I am not saying that everything that this guy can is taking some pretty steep points at people. Again, like I said, there are risks and rewards to all of these things. He's more on the risks of not using those non-renewable resources. But again, like I said, there are things he doesn't cover in this video that are risks of these non-renewable sources. So again, keep in mind what he's saying. The things that he is saying are measured things that have been published and are true, but you're getting one side of it as well. Now, what could also happen, my very smart class, what could also happen to our aquatic life that prefer the water pH be at a different level? Right, it could be a chain reaction, right? The ocean gets more acidic, therefore the mollusks die, and then the nasty negative yes. So one thing would be it could completely wipe out the ecosystem, or two, what has proven to happen to animals over time? What are some of these same scientists have shown us that over time, as like even think about back towards the ice age, right? Right, you're right, some species like dinosaurs didn't make it. So there were some species that weren't able to adapt and did disappear and did go extinct. But how many animals did not go extinct? How many other animals did not go extinct? Like lots of them, right? Like all the ones that are still on our planet today have lived through all kinds of changes, and I love that you guys already knew that they could adapt. So yes, it could be scary thinking that because of increases of pH that we might see this, right? Or we might see an adaptation. You guys are impressing me. All right, let's keep going. Awesome. So now, like this guy, how do you feel after watching his presentation, especially after the last section? How did that make you feel? No one. My opinionated class has no feelings. Yeah, right. A tad confused. Right. Well, I always like I in my I maybe I just always get anxious. I like when I listen to those videos, I like get immediate anxiety. Like, oh my gosh, the world is gonna get so much like so warm, and then the oceans are gonna melt and this heat is gonna be captured, and then what? Like our Earth is just going to burn away. Anyone else feel that way? Yeah, soon the world will be 100% water. Did anyone else feel like the doom and gloom of that video? Yeah, we won't be thirsty. Well, like I said, a lot of that data is true. A lot of those things could be possible projections, but again, a lot of factors are not put into that theory as well. So I don't want you to leave my class feeling like, oh, wow, like we really suck at taking care of our environment and we're killing it and we're going to burn up and we're on a ticking clock as to when this earth can't basically handle us anymore. All right. Because where we also are destructive, we also have countermeasures to take care of it. I do feel like if we would have went in, it talked about, what was it, the early 1900s, it talked about types of production. And thankfully, because that we have realized about some of this data, we are able to do some of these industrialized processes more clean. Does that make sense? My husband's job works with the EPA, an EPA requirement. That's our Environmental Protection Agency. And so with that, businesses can't just emit whatever they want. They can't just dump like contaminated water into like rivers like they had when we started human life here on Earth and the Industrial Revolution, where we started putting off mass gases and toxic things rapidly. I think that maybe our Earth did take a really nasty hit from that because it was something that we were unaware of, right? I feel like now that as we are doing these things, using our non-renewable energy sources and power plants, that we are doing these in a much more um, wise and less destructive way. Okay. So here it's just showing different types of carbon emissions put it out by country level. Okay, I'm gonna look at this. So this is a chunk of rest of the world. Here's some countries' emissions. All right, you can see Canada, Germany, Iran, Japan, Russia, India, the United States, China. But I want you to also look at this graph and kind of debunk it for me. What's different? Let's look at one of these smaller ones between Australia and the United States or China. What's different between Australia and the United States? I want you to think of the size. What's different in the size? Anyone? What's different in the size between China and Australia? Yes, Caden, thank you. Good, Xavier. Right. But think about how big China is. Think about how big the United States is. Think how big Russia and India are. They are huge countries. All right, so where you might initially look at this graph and be like, wow, the United States and China, Russia and India are putting out a ton of carbon dioxide emissions. You also, in my mind, when I logically think about it, well, yeah, we are, because if you're comparing my carbon dioxide in like export, it's not emission, all right, with all of these smaller countries, well, of course. Like, right? Of course, I would be. And then you also think about the stability of where these countries get their energy. All right. China and Russia are huge, huge exporters for natural gas and oil. All right, those are two fossil fuels that are major carbon dioxide emission like thieves. Yes, they did at one point. India is not far behind them. All right, so I think sometimes you can look at these things and feel very convicted, and I'm not saying we shouldn't feel convicted, but we also need to look at things like, wow, well, we're a bigger country. Well, yes, we are using, these countries right here are not only using fossil fuels for ourselves in our industries, but we're also exporting these fossil fuels to these other countries. So these other countries don't have it like basically on tap as quickly as we do because of the size and the availability of it in their country. So what are the effects of increased global temperatures? And that video covered a lot of it, right? Less ice in our glaciers, okay? Which also is going to be more carbon dioxide in our carbon emissions trapped in heat trapped in the water, which can increase the temperature of the globe. All right. The last one, and I would say this honestly could be more of a problem to me than even the carbon emission, is pollutants. All right. All of our disposables, all that handy stuff is really what's become quite a problem, right? Because when we bury things and hope that it disintegrates, that takes quite a bit of time. And again, do you think this is something that we've improved on in the last, let's just say last 5 to 10 years? Do you think we've improved on this? Yes. Yeah, good, Brianna. I know I'm a little bit older than you guys are, but I know in my lifetime for sure that there things that plastics that we've been using definitely have become, yes, well, both decompose and disintegrate. I'm sorry, guys, we're going long and I didn't even know it. But yes, I feel like we have a lot, just like Brianna mentioned, a lot of biodegradable options of things as of here lately. Okay. I feel like we didn't get to the rest of pollution. So go ahead and read about that today in class, but or in your extra bio time. But I feel like that is of the two things that is where you probably have more um, knowledge. Okay. So today, make sure you finish your quizzes for the week. We had two. We have one today. I didn't get that put on here. And I'm gonna put in the classroom some of that Nearpod with our renewable and non-renewable sources, so you can explore that. And we have a test this week. So if I am you, I'm looking forward to the next couple of days. I might even be doing my study guide today. I might even be looking at that test. I believe it is open. If you're feeling confident about where you're at with this stuff, I have no problem if you go ahead and start that. All right. All right. We are quiet today. Well, thank you for being here. I'll stick around for questions. If not, you're welcome to leave. Have a wonderful day. Another day step closer to spring break. I'll see you in the morning, guys.